Bhattacharya from 8th semester Mechanical Engineering in IIST Shippo. Currently, I am going to present my project on prediction of ATFL injury in inversion ankle sprain using OpenSim along with my two classmates Ashish Ghosh and Vivek Kundu. They are also present in this meeting and they will take the presentation after some time from me. This is the project work. This is the index which we are now going to talk about. What is the importance of our project work? At the very first situation of the COVID, we all face, as a mechanical engineering student, the crisis of data. In India, there is very few gate labs from where we get the data of simulation of work, simulation of walking, playing football, or anything, any simulation type of data. So now we are going to design a model from which we will able to develop the gait cycle, or more appropriately, we can say that we can analyze the muscle of the ankle, which is one of the most important body parts because it transmits the 83% of the load of our body to the ground. Why ankle is so much? Ankle sprain is so much important, and ankle sprain is the stretching, or in some extreme cases, tear of ligaments supporting the joints. The effect of ankle sprain compromising the normal walking cause muscle and pelvis to lose efficiency and strength. This is a major problem in the football or any playing term. So this project is very much helpful for the players also. The ankle is the meeting site of the foot and the leg segment. The term ankle joint collectively refers to the talocrural joint, the subtalar joint, and the distal tibiculofibular syndesmosis. The talocrural joint is the most vulnerable among the since 83% of the load is transmitted through this joint. As a result of this, the ligament group supporting the talocrural joint have the maximum injury frequency. This is the flowchart of the talocrural joint, by which we can see that one of the most important ligament here is this anterior talofibular ligament. We are currently working on this ligament. Inversion ankle sprain occurring due to an inward movement of the lateral part of the foot. The inward rolling of the foot puts the ligament on the outside of the ankle on stretch, possibly causing them to tear. Effects: injury to the surrounding musculature. Extreme cases can also involve fracturing of the ankle mortise. Risk of occurrence: study shows that up to 70% individuals who sustain an acute incident lateral ankle sprain are at risk of developing CAI over a short time period after the initial injury. We can also see several players from football are stopped their career due to this ankle sprain, and this is one of the major issue in the football game also. And in Indian scenario, we can consider this sprain can occur also for the kabaddi game, because there is a condition where some people are trying to stretch your ankle or stretch your leg by holding your ankle or holding the foot. This is some paper from which we take the motivation of our work. The investigation pattern of ATFL injury due to ankle inversion in different single leg condition landing configuration in OpenSim. The project required us to validate the model with results from the previous studies, determine the correlation between strength, stiffness, and viscoelastic coefficient of the ligament, determine the extent of the injury of ATFL in different landing positions, identification of the more risky landing postures. What is OpenSim? OpenSim is a freely available user extensible software system that uses the object-oriented programming to enable the user. So one of the major issue of us at the time of COVID is the data. So we are trying to solve this crisis of data for the student like us who don't get the scope to collab with a gate lab or to get the scope to collab with a hospital for the data. So this OpenSim, this project or the model developed by us is very helpful for the future study also. For this project, an OpenSim open source musculoskeletal model, toy landing model available in the SimTech library, which is taken by us. The model of the skeleton consisting of a torso, pelvis, and two legs has 23 degrees of freedom, 70 muscle tendon actuators. The lower extremities of the leg have two joint ankle, right and left, subtalar right and left, to represent the ankle. Ankle right and left represent the talocrural joint, and subtalar right and left represent the subtalar joint. One of the modification which is done in the model is there is lots of work going on this OpenSim software, but we are the one of the first few people who give the muscle to the model and analysis those muscle in MATLAB and different software also. So till now there is not much work where the muscle is considered and we take the muscle forces and different muscle and mechanical properties relation between the muscles and different mechanical coefficients. Now I want that Vivek Kundu take the presentation from here. Hello.
Good evening. We
can hear you.
Yes, sir. We have investigated different landing configuration of the OpenSim model as described by Shitabjo. Then the OpenSim model is simulated. The duration of simulation is 0.5 seconds, and the height of the model from which it is dropped is about 100 centimeters above the landing platform. Then solver generated data is exported from the OpenSim, and those data are analyzed to determine the strain and strain rate of the ligament, and that is fed to the mathematical model. Next slide. Next slide. We have used previous slide. We have used here the quasi-elastic model proposed by Jamwal et al. He has proposed the relaxation function GRT, where G1, G2, G3, and G infinite are relaxation coefficient, and tau1, tau2, tau3 are 3 time constants. Those values of these constants are we have got this the values of those constants by curve fitting of data, and the value of corresponding stiffness value K and the viscoelastic coefficient value C is given in the formula 2 and 3. We have calculated strain rate with these values and also calculated the elastic and viscoelastic coefficient with this equation. And now the part of model validation is there. We have seen that whenever the ATFL strain rate is high, the viscous coefficient is approaching 0. This happens because at very fast strain rates, there are not enough time for the ligament to relax appreciably. So the viscoelastic model approximates elastic model. This same conclusion has been made by Funk et al., which justifies our OpenSim model as results are matching. Next slide. These are the results we have got from our study. There are two data where the yellow line, where is base plate of the OpenSim, is parallel to horizontal plane, and the black line represents when the base plate is an angle 30 degree with horizontal plane. The median values of ligament stiffness are plotted here. Next slide. The normal range of ligament stiffness is reflected in the graphs as -20 degree to +20 degree range. A body tilt angle outside this range has considerably higher probability of injury as reflected by the corresponding strain values. Also, the values of ligament stiffness is only valid if the ligament is within the limit of maximum strain. Also, we have seen that for forward tilting body, the chances of landing on the front foot is higher than landing on the heel. This is reverse for the backward tilting body. For the higher body tilt angle, the degree of plantarflexion is much more than the lower values of body tilt. Hence, the higher values of stiffness and chances of injury is also higher. Next slide. This is our conclusion that we have seen that in the body tilt angle range -20 degree to +20 degree, the chances of injury are more when the body is forward tilted. The variation of ligament stiffness has similar pattern in both scenarios. The relative risk of injury due to overstretching of ligament is more in case of forward tilt than backward tilt. Also, the tilt angle of the base plate induces more higher degree of plantar flexion while landing, as shown in the figure, in the variation of degree of plantar flexion with body tilt. Now Ashish will continue.
Good evening.
I would like to, next slide, please. Yes. I'd like to continue with the limitations and future work of this project. This model does not take into account the time dependency of ligament stiffness. The study cannot be used to predict the risk of recurrence of inversion sprains, and the effects of ligament conditioning have not taken into account in this study. Those are the limitations of this work, and the future and the final form of this project, as we envision it now, will include end-to-end product involving the very advanced pose detection algorithms, which we may use to detect the pose from the virtual environment where we are currently simulating these landing scenarios, and they can be further down the line used to train athletes in order to reduce the risk of injury in different sports. Currently, similar type of technology is already in place in the MRF PACE Foundation, currently operation in Chennai. Next slide, Chitra. These are some of the projects that we have referenced our studies from. Next slide. Yes. In these testing times of COVID-19 pandemic, the most affected segments of the society and the student community who are currently detached from their peers and colleges. And in such a situation, working on projects in both academic and co-curricular in nature has been particularly difficult given the limited opportunities of interaction with the entire group. And as Shitabjo rightly mentioned at the very beginning, the lack of availability of data. We are extremely gratified to Dr. Vidyut Pal for motivating us and guiding us to the entire length of the project till completion. Recognition is also an integral part of a project's success, and we also sincerely express our gratitude to GAABESU for considering our collective works for the 1965 Emmy Research Award donated by 1965 Emmy batch. Further, this project has been presented at the International Conference on Application in Computational Engineering and Sciences 2021, held at VIT Chennai on the 20th and 21st of October 2021. And the abstract of this project has also been accepted on January 28th, 2022 for presentation at the World Congress of Biomechanics to be held at Taipei City, Taiwan on July 10 to 14, 2022. Thank you.
Thank you, Ashish, and for the concluding remarks. Excellent work in kinesiology, right? Biomechanics.
Yes.
Okay. Any question? Any question from the audience?
Yes. I would have one if you have time.
Absolutely.
Okay, Ashish and YouTube. I'm a mechanical engineer in 1965 ME. We are the one that is sponsoring this thing. So congratulations. This is the only one that I could say I understood about 90% of the presentation. The others I would say below 50% most of the time. And that's because I'm a mechanical engineer and the topic you picked was really quite obvious, the mechanical guy. Mechanical is always simple to follow. Electrical others are a little bit tough, that take more of a brain time. Anyway, I like the idea that you did some simulation, excuse me, on your own, the group, sorry. And that's something we really like to see more, that whenever somebody is doing some experiment, that you do generate your own data and your conclusion. The particular things that you're thinking about doing in future, very encouraging. I wish all of you more success. I won't take any more time. Again, congratulations. And on behalf of the 65 ME group, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, Vidyut. Thank you very much. Any other?
This is Arup Bhattacharya. I compliment you for this kind of work. It's very interesting, very exciting. I'm not a mechanical engineer, but I understood most of what you're doing. You're paving the ways to some very complex way of looking at the effects on the human body, and go for it. It has a lot of possibilities. It'll open up much further work in this direction, and I compliment all of you for that. Thank you.
Thank you, sir.
Thank you, sir.
Good. Good comments. Thank you very much for excellent work. All right. So we are going to move on now to our last but not least presentation. Subhajit Biswas, ME fourth year. It's a winner of the Ashok Kumar Sarkar Undergraduate Fellowship donated by Mr. Avik Sarkar, IIT Kanpur, presently at USA. So Vajit, you got 23 slides, so you got to choose a few or skip a few rather. Okay, thank you.
So my screen is visible?
Yes.
Okay. Thank you. Respected alumni and my fellow friends, thank you so much for participating to presentation of our research article. And I am also thank you for our supervisor, Professor Bijan Kumar Mondol, Department of Mechanical Engineering. And I am also thankful our co-authors, Rahul Dorai, P.R. Shmolik, and Sumit Kumar Ghosh. So our co-author Sumit Kumar Ghosh has already discussed of our another research article, that is the mathematical model of a grid interactive incorporating of a solar parabolic tau collector with a hydraulic accumulator system. So our next research article is the variable refrigeration flow system and emerging technology in HVAC industry. So in this presentation, this is the overview of the presentation. We can see that the introduction, refrigerant features and the components of a VRF system and schematic representation of heating mode and cooling mode and heat recovery mode, schematic representation of the heat recovery mode and the coefficient of performance and advantage and limitation and application of the VRF system. And we can discuss also about the COP and energy efficiency ratio and the reference. So first of thing, the question arises that what is the VRF system? Actually, the technology, the VRF system has invented in a Japanese company, the Daikin, in 1982. Actually, Daikin called the technology by the name of the VRV system. Actually, VRV's full form is the Variable Refrigeration Volume System, and the name is trademark of Daikin. So other company are called telling us the VRF system, that is called the Variable Refrigeration Flow System, but both things are same, but the name are different. So the simplest explanation of the VRF system is to explain it is a large scale of ductless HVAC system that has capability to perform a high capacity. It is also called a multi-split type air conditioning system with one outdoor unit corresponding you can use the multiple indoor unit. In this technology, cooling or heating is adjusted by adjusting refrigerant flow, and which is achieved by changing the speed of the compression. So this is our refrigerant. In this refrigerant are chosen considering the various parameters, that is the affordability and efficiency, performance, safety and reliability, environment and economical, and GWP, that is the global warming potential, and OWP, that is the ozone depletion potential, and TEWI scale. This is the mode type of refrigerants used in the VRF system. So the main features of the VRF system is the zoning system. The main advantage of the VRF system, it is ability to respond individually to fluctuation in space load condition. The user can set temperature of his or her room according to the requirement. And it is the VRF system has actually three types, actually the heat pump, heat recovery, and only cooling. So in these cases, VRF system, we have seen that the simultaneously cooling and heating is required. Actually, VRF system are capable to simultaneously cooling and heating. Each individual indoor units can be handled separately by the user using a programmable thermostat. Most of the VRF manufacturers offer a centralized control option, which enables the user to monitor and control the entire system for a single location. So this is the main components of the use in the VRF system, that is the inverter driven compressor, definite joint, four-way valve, and expansion valves. That is the schematic representation of the heat pump VRF system. That is the operation mode of the heat pump VRF system in cooling mode. Actually, heat pump system has two types. One is the heating operation and one is the cooling operation. And at first, in cooling operation, the DC inverter compressor takes refrigerants in from the accumulator. So some oil is also supplied smooth functioning of the crank, and the refrigerant oil and mixer is passed through the oil separator in this process, and the oil from the refrigerant gas separated from the special black to the condenser, and the hot gases process in four-way reversing valve, and the mode enabled to cooling mode. And in this compressor, the pressure of the gas decreases. Hence, the high temperature of the high pressure changes to medium pressure, medium temperature condensate liquid. The condensate liquid will be passing to the NRV valve, and the condensate liquid is passed through the plate heat exchanger, and it further reduces to the quantity of the gas present in the condensate gas. It also reduces the temperature of the liquid, and the liquid output of the plate heat exchanger is temperature less condensate liquid. So the temperature, so the liquid is the given indoor unit via electronic expansion valve, which further reduces the pressure of the liquid. The output from the electronic expansion valve is low temperature and low pressure of liquid. So the medium temperature and medium pressure condenser gas all the way output indoor units to the accumulator. And the next is the operation of the heating mode. Same cases in the cooling mode operation. In these cases, some hot refrigerant to the oil separator goes to the four-way reversing valve, and four-way reversing valve direct to the indoor unit. So in these cases, indoor unit act as a evaporator, act as a condenser. So as a result, the refrigerant is going to be cooled, and the cooled refrigerant goes to the NRV valve, and then goes to the plate heat exchanger and goes to the outdoor units, and outdoor units has a hot air, so the heat exchange between them, and then this hot refrigerant and goes to the accumulator. This cycle is completely working. So the next is the heat recovery system of VRF system. Actually, we know that the VRF system flow system has a heat recovery, can be operated in both heating and cooling modes at the same time, enabling to heat to be utilized rather than discarded as in standard heat pump systems. So VRF heat recovery system has advanced technology, some as inverter drives, pulse modulating electronic expansion valve, and disturbed controls, allowing to system it to function in either net heating or net cooling mode, depending on the needs of the area of the spaces. So this is the operation mode of the heat recovery VRF system. In these cases, the compressor has leaves the hot refrigerant, and this hot refrigerant goes to the hot gas line, and it depends on the needs to the room temperature, where it needs to heating mode. Then the heat pump, and then the heat is open, and the hot gas line, through the hot gas line, the hot refrigerant goes to the heating room, that is the indoor room, indoor unit 2, and it's evaporated, and then goes to the cold refrigerants, goes to the NRV valve and flow through the liquid line, and then the another room has a cooling mode. Then liquid line is cold refrigerant has presented, then cold refrigerant as goes to the electronic expansion valve and goes to the indoor unit 3, that is need to be cooling. So it gets evaporated, and this evaporated cooling refrigerant goes to the passes to the suction line, and this suction line goes to the accumulator in this pathway. So this is the simultaneously heating and cooling in the same refrigerant using the VRF system. So this is the coefficient of performance to find out the COPH in heating mode and COPC in cooling mode. Now, in this equation, we can see that the heating mode COPH is equals to QH divided by heating power plus PC plus PE plus PD, where PC is equals to the report variable for the electric consumption rate of crankcase heater. PE is the report variable for electric consumption rate of evaporatively and cooled condenser water pump, and PD is equals to the report variable for average default power of the simultaneously time step. And the same is the cooling mode is conditioner. In QC is the total heat supply during the cooling process. So the next is the advantage and limitation of the VRF system. Actually, VRF system has a less space because in these cases, we can see that the VRF system has one outdoor unit, but multiple types of indoor units. So the less space is required. And the most important thing is in the VRF system, do not use normal compressor. We used in the inverter compressor because normal compressor RPM is fixed. So inverter compressor RPM do not fixed. If load is increasing, then speed also be increased, and load is decreasing and speed also be decreased. Another reason is compressor do not stop permanently as a result, but actually inverter drive compressor has slowly run. As a result, power is more consumable and saving power, and power saving is to be 30 to 40%. And the cons is the less reliable and cooling capacity reduces at lower indoor temperature. And the application of the VRF system is the hostels, the business and buildings and schools, hospitality, nursing home, etc. And this is our results and the coefficient of performance and energy efficiency ratio of the VRF system. In this slide, we can see that the figure 2 illustrate that when the evaporator pressure are increased, COP gets decreases. And the figure 3, we can illustrate that the opposite trends at the compressor pressure was increased, and increasing the pressure on the evaporator side reduces compressor effort. However, increase the pressure on the condenser side needs to more compressor work. As a result, the cooling and ambient temperature determine these two pressures. So this is our conclusion. So in this presentation, we have established the many phases of the variable refrigeration flow technology. The content has been able to outline the most important aspects of the concerning the evergreen formulation of the technical evolution that is the arisen out of necessity, and owing the scarcity of the detailed case studies and intense depends of the most estimation use remain concerning the magnitude of energy and performance can be realized, and project depending on retrofitting and our other prime importance, especially where cooling capability needs to be adjusted when there is no ductwork and where space is contained, the determination, performance, payback, accessibility, and to the public and the situational experiment was the technology will mold how it is application grows. So this is our conference paper. We participated in IME 2021 present on 17 December 2021. That is a mathematical model of a grid interactive solar incorporating solar parabolic tau collector with a hydraulic accumulator system. And we also participating in IAME 2021 present on 18 December 2021. That is the variable refrigeration flow and emerging technology in HVAC system. And we also participating in AMI IIM 2022 that is present on today, and mathematical model of a grid interactive solar parabolic tau collector integrated with the hydraulic accumulator system. So this is our references are used in making the VRF system, and thanking you.
Thank you very much, Subhajit. Very interesting.
Thank you, sir.
Any comments, questions?
Yes, Nihar, I would like to add a small thing. Since this is very close to, this subject is very close to my profession. I'm an architect.
Right.
So this system, I would only like to know, or I would rather like to say that in the end of his presentation, he says that VRF system is not reliable.
Yes, sir.
I totally disagree with that. VRF systems are very, very reliable. And there is another point made that it has one outdoor unit. No, it can have several outdoor units.
It gets one outdoor unit corresponding to multiple types of the indoor units.
No, listen to me.
Okay.
It can have several outdoor units with several indoor units, and it has been extensively proved that it works very, very well. So I do not know from where you got this information that it is not reliable. It is very, very reliable and is being used for all intelligent gold standard buildings.
Yes, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you. Yes. Any other comment? Any other comment, questions? No. Well, Subhajit, thank you so much for your excellent presentation. Take all those things in your consideration and do some literature studies, and maybe you can talk to Mr. Shen and get some more advice as well. So practical application is very important, right? Whatever we do. Yeah. So we always learn, whenever happens, you keep on learning. So things, yeah. Okay, so that concludes our presentations, all those formalities, and thanks to everyone, all the students. Well done, excellent work. Very proud of you guys. And I'm going to invite at this time, Madam President, yeah, she's here, to say a few words and conclude our event for the day, or the evening rather.
Madam, mute achen.
You're on mute.
Yeah, Nihar, thank you. I mean, it is, after such intense, presentation and discussion, it's really difficult. Anyway, I'm extremely overwhelmed, and it requires really some deep-seated research work to come up with such a report and presentation. Congratulations to our beloved IIST students who has won this GAABESU Research Award 2022. Wish them all the best in their continued research work. I'm sure our reviewers had tough time selecting the winners for this award. Like Probitda, Orubda, and Niharda, we would like to assure them all the support in their future, in their continued research work. Also, I would like to mention a few individuals whose brains and efforts have gone in, making this program as a success. Sincere thanks to the GAABESU Research Award donors. In fact, other than Boidoda and his badge, and few others, Madhusudanda, we mostly, Ribendra Acharya, we mostly do not know them. Thanks to them. Thanks to our fund managers, who has been, fund managers, mostly Shopon Shaha and Shubroto Ghosh, based out of US. They have been, meticulously managing this fund to, give away this research award for past so many years. And of course, thanks goes to our reviewers, Dr. Nihar Biswas, Windsor University, Canada. Niharda has just moderated this program so well. We have Dr. Parthopratim Chattopadhyay, Director, NIFFT. Partho was here. He was having some questions for the project by the metallurgy student. Dr. Gautam Chatterjee, NASA, based out of US. I don't know whether he's here or not. Thanks to our hosts, Tultul Roy, Shreya Nandi, Amitabh Das. So congratulations to all of you to make this program as a success. Thank you all, and good night and good day. So let us call this